All right, so in this video, we are going to take a look at how to detect the species of an iris flower with principal component analysis. Why principal component analysis? Well, it's a method of dimensionality reduction which attempts to distill higher dimensional data down to a smaller number of dimensions while still preserving as much of the variance in the data as possible. And what it's doing is it's finding hyperplanes. So I made a description of what those are in my support vector machines video, so you can reference that if you like. But basically, we're finding hyperplanes in data onto which our data set can be projected in order to create a lower dimensional representation of this data. Now let's take a look at how we can actually use this with some Python code and the iris flower data set, okay? So scikit-learn includes a data set for iris flowers which has 4 features: the petal length, petal width, sepal length, and sepal width. And it also has a single target variable with 3 possible values, with 1 value for each species of iris. So let's say we want to visualize the relationship between these features and their corresponding species. In order to do this, we're going to need to reduce the 4 dimensions or features down to 2 or 3. So for the sake of this example, let's reduce the number of dimensions down to 2. And we'll start out by loading the iris dataset and examining its number of samples, number of features, and target names or species. Okay, so we're loading the iris dataset here. And we're assigning the num samples and num features values here. So we have 150 samples, 4 features, which is what we just described, right? And here are the species names: Setosa, Versicolor, and Virginica. Now, let's use scikit-learn's principal component analysis function, or the PCA function, to identify the combination of attributes or principal components or directions in the feature space that account for the most variance in our 4-dimensional iris data. All right, so here we're assigning our variable or features to the iris data. Our PCA is a PCA with a number of components of 2. We're going to fit that and then transform it to XPCA. And when we look at the resulting vectors, this is what we get here. Now, how much variance was captured with just these 2 dimensions? We can find out by looking at the explained variance ratio. And so 1 dimension gives us 92, the other 5 combined 97. So what these numbers are telling us is that basically 92% of the variance was captured in the first dimension alone, which is pretty interesting. 5% of the variance was captured by the second dimension, and this means that we were able to preserve a total of 97% of the variance while only losing 3% of it by reducing our 4-dimensional data down to 2 dimensions. Now let's visualize that in 2 dimensions. 2 dimensions meaning we have a flat plane with an x and y axis, right? And we can see here that the clusters within this plot help us to see that the size of iris leaves basically can assist in the classification of iris species, right? We've got our Setosa in red, Versicolor in green, and Virginica in blue here. So hopefully this video was helpful for you, and I appreciate your watching, and we will see you in the next one.